All right, let's jump right in. Have you ever stopped to think about this? How on earth do you scientifically study something you can't see or touch or hold in your hand? Like a thought or a feeling, a memory. We all know they're real, but they're not physical. Well, that right there is the central mystery for psychologists. And today, we're going to go on a quest to figure out exactly how they tackle it.
So, to kick off our quest, we've got to understand the challenge. We need to, survey the scene of the crime, so to speak. We have to define the core problem that makes psychology one of the trickiest sciences out there.
I mean, let's just put it out there. How do you pin down a feeling with the scientific method? It's not like measuring the boiling point of water, right? This single question basically turns all of psychological research into a detective story. It's this incredible quest for evidence about the most elusive subject you can imagine, the human mind.
So to solve this case, our detective, the psychologist, is up against some serious obstacles. For starters, the mind is intangible. You can't put a memory under a microscope. Then there's the fact that every single person is unique, so what's true for me might not be true for you. Our feelings are also super fleeting, changing from one moment to the next. And you can't just study one tiny part of a person, like their motivation, without considering the whole person. It's this complex, kind of messy, and deeply personal world that psychologists have to find a way to navigate scientifically.
Okay, so given all those challenges, how does our detective move forward? They can't just go around looking for clues that confirm what they already think. No, they need a much more powerful, more rigorous tool. And this is where the whole quest gets really interesting.
This quote gets right to the heart of it. It's an idea called falsification. You see, instead of trying to collect a bunch of evidence to prove you're right, you do the opposite. You design studies that try as hard as they possibly can to prove you're wrong. And if your theory can actually withstand all those attacks, well, that's when your confidence in it really starts to grow.
And this just illustrates the difference perfectly. The common sense way, what we all tend to do, is verification. We go looking for white swans to prove our theory that all swans are white. But here's the catch. Finding a million white swans doesn't actually prove the theory is true forever. The scientific method, falsification, does the opposite. It goes looking for that one single black swan. Why? Because finding just one is enough to prove the theory is definitively wrong. It's just a much, much higher standard of evidence.
So this whole process kicks off with a hypothesis. Just think of it as a super specific, testable prediction. But here's the thing, there are actually two of them. The alternative hypothesis, or H1, is what the researcher really thinks is going to happen. Something like this new therapy will reduce anxiety. But the real target of the study is the null hypothesis, H0. The null always predicts that nothing interesting will happen. This therapy will have no effect. The entire point of the experiment is to gather enough evidence to confidently say, you know what, the null hypothesis is wrong.
So with a clear hypothesis ready to go, our detective now has to choose the right tool for the job. They've got to pick a research method that can actually put that no-effect idea to the test and see if their own prediction holds up.
And believe me, there isn't just one single path. Psychologists have a whole toolkit of methods, and they branch out all over the place depending on the goal. Some paths, like a really controlled lab experiment, are built to isolate cause and effect. Other paths, like interviews or just observing people in the real world, are way better for just describing how people behave naturally. The method you end up choosing depends entirely on the question you're trying to answer.
Now this is an absolutely crucial distinction. In a true experiment, the researcher has a ton of control. And the key, the secret sauce, is random assignment. That means every single person in the study has an equal chance of being in, say, the therapy group or the control group. That's so powerful, because it helps make sure the groups are pretty much the same to begin with. But in what's called a quasi-experiment, you can't randomly assign people. You have to use pre-existing groups, like comparing students who chose different classes on their own. It's still super valuable, but it's a lot harder to say for sure that the teaching method and not some other difference between the groups is what caused the results.
You've probably heard this a million times, but it is so important it's worth saying again. Correlation does not prove causation. A correlational study can show you that two things are related, like ice cream sales and crime rates. They both go up in the summer, but that doesn't mean eating ice cream causes crime. There's a third variable, right? Hot weather. It's probably causing both. Only a true experiment where you can actually manipulate one variable while holding everything else steady can get you close to proving a real cause and effect relationship.
So no matter which path a researcher takes, whether it's an experiment or a correlational study or just observation, every single study is built from the exact same fundamental parts. These are the building blocks of the whole investigation: variables.
In an experiment, you've got two main players. The independent variable is the one thing the scientist changes on purpose. You can think of it as the cause. So in our example, that's the type of therapy people get. The dependent variable is what the scientist measures to see if that change actually did anything. It's the effect. In our case, that would be the level of anxiety. Simple, right? You change the independent variable to see if it causes a change in the dependent variable.
But hang on, this brings us right back to our original problem. How in the world do you measure something abstract like happiness or anxiety? This is where a really clever concept called operationalization comes into play. It's just the process of turning a fuzzy, abstract idea into something concrete and measurable. You can't measure happiness with a ruler, but you can measure the number of times a person smiles in an hour, or you can have them rate their happiness on a scale of 1 to 10. You're basically making the unmeasurable measurable. It's genius.
Okay, so our detective has picked a tool, they've identified the variables, and they've figured out how to measure them. They've gone out and collected their evidence, their data. But before they can draw any conclusions, that evidence has to pass a really strict quality control test. So, any good measurement has to have two key qualities: reliability and validity. Let's break that down. Reliability is all about consistency. If you step on your bathroom scale 3 times in a row, does it give you the same weight each time? If so, it's reliable. Validity, on the other hand, is about accuracy. Is that scale actually measuring your weight, or is it secretly measuring your height? A good tool has to be doing what it says it's doing.
Let's make this crystal clear. Imagine you have a ruler made of some weird kind of wood that randomly shrinks and expands throughout the day. That ruler is unreliable. It's not consistent. Now, for the other side, imagine using a perfectly consistent bathroom scale to measure someone's intelligence. The scale is super reliable. It gives you the exact same number every single time, but it is absolutely not a valid measure of IQ. A good psychological tool has to be both. It needs to be consistent, and it needs to be accurate.
So, after all these steps, framing the question, creating a hypothesis, picking a method, and gathering good, solid, reliable, and valid evidence, where does that leave our investigation? Have we reached the end of the quest for an answer? So here it is, the whole journey, all summed up. You start with a question, you form a testable prediction, you choose your tool, you collect good evidence, and then you see if that evidence is strong enough to let you reject that no-effect idea. But look at that last step. Every answer just leads to new, more specific questions. The quest, it turns out, never really ends. And this brings us to the biggest takeaway of all. Psychological science isn't really about finding one magical proof. It's a slow, careful, rigorous process of elimination. And this rigor is more important now than ever. You might have heard about the replication crisis in the field, where some famous findings have been tough to reproduce. But that doesn't mean the science is broken. It actually means this process of elimination, of constantly challenging our own findings, is working. It's how we get closer and closer to the truth, by systematically ruling out everything that's false. So I'll leave you with this final thought to chew on. If science, at its very core, is a journey of disproving things, not proving them, how does that change the way you think about the term scientific fact? It kind of suggests that our knowledge is always a work in progress, always open to being challenged, and that it only gets stronger as it survives every single attempt to prove it wrong. Definitely something to think about.